We're going to look next at inequalities that don't have just an x, but that have an x and a y together. Two variables, so two variable inequalities. Let's start by making sure we understand what it means to solve a two-variable inequality. What it means is, when I put these numbers in for the x and the y, I end up with a statement that is true. If that happens, then the ordered pair is a solution. If that doesn't happen, then the ordered pair is not a solution. So let's take a look here. We're just going to do some checks. I've picked some points. There's nothing special about them. I just picked them kind of scattered around. Let's look at this very first one together. We're going to see how things work. So this is the x coordinate. This is the y coordinate. We want to know if this is a solution to this inequality. Here's how you can check. Put the 4 in where the y is. Put the -3 in where the x is. And then just see if what you get is a true statement or a false statement. So let's simplify. -3 plus 1 is -2. Is 4 greater than or equal to -2? Yes. Yes, it is. So this is a solution. The ordered pair, and I'm going to give it a little highlight, -3, 4 is a solution to that two-variable inequality. It makes that statement true. Let's take a look at the next. How about for B? Let's do 5, 1. So 1 is the y coordinate. 5 is the x coordinate. 5 plus 1 is 6. Is 1 greater than or equal to 6? No, 1 is less than 6. This is a false statement. That means that this ordered pair is not a solution. So -3, 4 does solve the inequality. 5, 1 does not solve the inequality. Do at this point a quick pause. I want you to try these next two and then unpause when you're ready to check them, see if we match up. Okay, y coordinate, x coordinate plus 1. Is -3 greater than or equal to 1? No, -3 is less than 1. This is not true. So this ordered pair is not a solution. Next up, -5, -2. So -2 in for the y. Is that greater than or equal to -5 plus 1? Well, -5 plus 1 is -4. Is -2 greater than or equal to -4? Yes, -2 is greater than -4. So this is a solution. I'm going to give this a highlight. So we saw A was a solution and D was a solution. So here's where we are. We've seen that some ordered pairs are solutions, some are not. We can check individual ordered pairs, but it kind of takes a little while. I mean, we looked at 4 ordered pairs and it took us a few minutes. If I asked you to check 20 ordered pairs, or 100 ordered pairs, or 10,000 ordered pairs, you'd be busy for quite a while. It turns out there is a more efficient way. We're going to, just for a moment, pretend that instead of a greater than or equal to, it just says equal to. So just for a moment, we're going to pretend that instead of an inequality, it's an equation. This is going to then graph a line for us. So let's remember, it's maybe been a while. Start with the number at the back. That's your y-intercept. So put a point on the y-axis at 1. And then use your slope number. And if there's nothing written in front of the x, assume it's a little 1 over 1. That means to get to another point on the line, you're going to go up 1, right 1, up 1, right 1, up 1, right 1. Once you've got more than one point, you can now draw your line between them. I'm going to take advantage of my line drawing tool, which I use to draw lines. Now this line's a little bit too big for my taste, so I'm going to make it red and a little thinner. Okay. So here's what we did just for a moment. We pretended that instead of an inequality, it was just an equation, an equality. That got us this line. Here's what I want you to notice. Do you see how the line split the ordered pairs that were solutions away from the ordered pairs that were not solutions? It actually turns out that if you have this line graph, and if you know where a solution is, then actually all, all of the ordered pairs on that same side of the line will also be solutions. And we represent that by coloring in or shading in one side of that line. Now, there are some more things to be careful about. We'll look at that in the next part of the lesson, but here's the big idea. When you want to solve a two-variable inequality, you're going to get a colored-in region, and the way you can check for individual solutions is just seeing whether those ordered pairs make the inequality true, like points A and D, or false, like points B and C. So A and D were solutions. They're on the colored side. B and C were not solutions. They are on the unshaded side.